So I'm going to use PyCharm because it's easier to do Python related things. I already have a test project here, Python project, but I actually don't think I'm going to use that. I'm going to create a new one. So a new project, and then I'm actually going to put it into a repo that I have. Maybe I should create a new folder under here called Python. Then I'll say, okay, well, this is going to be, let's like choose a project to kind of just build on top of to learn some object-oriented programming. I'm gonna call it maybe Study Buddy. Okay. Basically choose your environment. Have Python 3.2 or 12, and then that's about it. Okay. So you're automatically being put into a virtual environment right here, specifically for the Study Buddy. I'm just going to use a terminal here. So I'm right here under Study Buddy. If I do ls, not much. I think it's because virtual environment is a hidden folder here. All good. Every time we create new projects, it's good to always make a test file so that you can actually just see whether or not everything is working correctly. I like to just add files to Git separately, so I don't want to add it. If I did ls here again, I'll finally see my main.py. Now, first things first, just adjust this a little bit. Simply print hello world. Okay, and then if I were to go down here and run that with Python main.py, get hello world. So the reason why we actually don't need to do something like Python 3 main.py is because we're already in a virtual environment, right? So Python is already recognized. The specific Python version is already recognized. So we can just do Python instead. So it's like a convenience thing. So if you're wondering how come we do Python 3 sometimes or Python 3 is used for like the global system when you're not under a virtual environment, and Python is used for virtual environment. Okay, so object-oriented programming. So how do we actually start? Usually the easiest thing is just to make a basic class. So a basic class is just a definition for all the objects that you will actually instantiate from. So for example, let's just call this class card. Okay. I think it's just like this, right? Okay, so we'll make a class card, and every single class has a constructor. A constructor is basically the first function that runs whenever you create a new object from the class. So think of a class as a blueprint. And anytime you create a new object, you're creating some sort of instance or manifestation of this blueprint. So if you were to think about baking, your class is like a cookie cutter, and then the objects are the cookie that you cut from dough. Okay? So that makes sense, right?
Yeah.
So the constructor here is basically defining the initial shape and setup of the cookies you will be cutting with this stencil. If that makes sense.
So it's more like a template?
Yes, it's like a template, kind of. Okay? So def init. So the constructor is defined to be def init, always dunder init dunder, right? Dunder double underscore init double underscore. And you can actually have something that you can you can do whatever you want here, basically, right? One of the things that we like to do is kind of set up instance variables for the specific object. So every object that is built from a class has its own set of variables. We call them instance variables. We can dynamically assign new variables to that object, right? Specific for that, not at the class, but to that object, okay? And I'll make that clear later. So let's just say this self.label, okay, is going to be something empty. Self.description is going to be something empty, okay? Something very simple for now. So what this means is that, okay, well, this is what we call a constructor, the method, a function that basically runs to build out an object from this blueprint here, this card, right? So we have two variables that we associate with every single object. They get their own version of this, right? It's called underscore label and underscore description. How do we know that it belongs to that object? It's through the self keyword. Self, right, is a special variable that always points back to the current object belonging to this class. So when we do self.label, we're essentially creating or attaching this label variable to the self object. At some point, let's just say here, at this point here, self actually does not have a dunder label, right? You basically create one the instant you actually add or assign a value to it. Does that make sense?
Yep.
So let's just say when the code is here, right, there is no underscore label. But after you have initially assigned it, at this point right here, self underscore label exists. Right? Makes sense of it, right? So like these belong to the object, not to the class. So what this means is that, again, every single object you create from this card class up here, right, is going to have a different version of label and description. Okay? Now, every single class defines more than just a constructor. Constructor is just run whenever you actually want to create an instance of this class. So I'm just going to do that real quick. So we're outside of the card now, okay? So we can just say my card equals card. And this is actually how you construct an instance of the object. Okay?
Mm-hmm.
So right now it's nothing. It's default. How do we know that? We do myCard.label. Okay? I don't know. It should be able to access it. It's just not proper Python. These are what we call private variables. So it's just okay. If we were to test it out right now, oops. You'll see that we didn't print anything. Okay, it came out empty. But we did something like this. My card. Okay. My card equals 1, 2, 3, 4, 5 string. My card label. We just like assign it directly. You see how it prints out, right?
Yeah.
And the next one doesn't print out at all because there was just empty string.
Mm-hmm.
But we forcefully assigned this one.
Yeah.
Okay, so this is usually what underscore variables are by convention. What we call private variables. You can't really access them directly. Notice how like your IDE, in this case PyCharm, doesn't really give that to us.
Mm-hmm.
It doesn't hint at it because it's like, oh, you know, underscore usually means private. You can't really tap into it directly from outside of the class, right?
Mm-hmm.
So, okay. So how do we actually set these things?
We use setters and getters.
Yeah, so you define methods, right? That will allow us to set and get values. So that's how you can actually have things outside of your class actually update these internal variables.
Mm-hmm.
Okay, so let's say this. Let's say we want to be able to have a user, and in this case, a user is almost always a software developer in our perspective. We want to have a user be able to modify the label, right? So how will we do that? We'll just define a method to just update that. Okay, so we do set label. Okay, well I think Python does something like this instead. That's like the better
Yeah.
convention. Yeah. So then notice how our IDE all of a sudden automatically fills in self. Okay? Because it is what we call a method in the class. So the set label is a method belonging to the card class, meaning that every time, in order to call this little function here, or in this case now a method, you must call it against an associated instance of card. And this self here, this first argument to any of these types of functions, make it so that now it is considered a method. Meaning that you must have to, like, in order to call this function, you have to basically call it with an instance of that object or class. Okay? Does that make sense?
Yeah.
Okay. So what that allows you to do now is that since now you're inside the card class, you can still access all the private stuff. You notice that?
Yeah.
So I'll do label, and I'll give a parameter value. Okay, we'll just say label. Okay. You can do something like this to assign.
Yeah.
Okay. So now when I do my card, and I see I have a public method now here. I can just use set label, and I can give it a value. Okay. It automatically knows how to pass self automatically. It's with my card. Notice that?
Yeah.
Yeah, self is a card type by convention. So then it knows to automatically pass in my card as the first argument, and then the second argument is going to be whatever you want. So let's just do in this case, let's do IP or I say layer 7. Let's just say layer 7. OSI layer 7. Okay. Let's just give that as a label. Okay. Now, what we can do is we can add it, since we can't really access underscore label directly, what do? We want to access it. Well, you have a setter, you can then define a getter to get that too. Get label. Okay? And we just simply do return self.label. Again, you have access to all the private stuff here because you're still under the card class. Everything here is still under the card class. Okay, so that's why you're able to still access stuff that's private. So we can do something like this. My card. What does get label return? It returns a string, right? If you go self label, this is actually a string. It's intended to be a string. So we can do this. My card get label, and we have no arguments, only the card itself. Okay, so we're able to just do it like this. You just type it this way. So if we were to just run it again, you'll see that we printed out the label this way.
Okay.
Now, if you do not, again, I just want to remind you, if you do not set label, every time you instantiate a card object, you just basically set this up, right? That's the function you call. This type of syntax here, the class with the parentheses, is basically calling the init method. Okay, so now we set this up. We set up all the private variables with the values we want. Okay, so if we were to say get label, what do you think is going to happen?
There'll be nothing.
Yeah, it's empty, right? Because we didn't even like do anything with all the variables that we have available to us. So that's why you need to do something. Okay, that's why you need to actually override those default values with that set label. Okay.
Yeah.
All right. So that's cool. Like now we can just go on our merry way and do a set description too. Okay, with description. It's straightforward at this point. Then we do self.description is equal to description. Okay. Then we can do a def get description. Then we can just return description this way. Okay. So then we can say my card dot set description. It can be something like this is the application layer of the OSI network model. Okay. So we can do get label, and I think we can just f string this
I don't think we need the semicolon.
Oops. And we need a extra string. Go ahead. Okay. So that works. Okay. So that's one card. That's one card.
Mm-hmm.
So how about if we did a second card? This way. Basically, what ends up happening is now we've called the constructor again,
Yeah.
and that returns back a new instance
Mhm.
of that object. What do you think then now, if we were to, let's say, print this again,
Mm-hmm.
okay, but instead print out my card 2, what do you think is going to happen?
It's going to be an empty string again, or empty string.
Empty strings, you see
Yeah.
that? Because they get their own copy of label and description because it's itself.
Yeah.
It's the instance of the object.
So it's like kind of like making the second cookie.
It's a second cookie.
Yeah.
Right. It's a second cookie. So I have to do something here. I have to, if I want it to have a new label,
Mm-hmm.
I have to set a new label. Okay, so I say now it's OSI layer 6. Okay. Now I'm going to say now it is going to be, this is the presentation layer of the OSI network. I think it's the presentation. Okay. Okay. So if I were to run that again, I actually have two instances. Okay. My card 2.
Mm-hmm.
Okay. Okay. All right. So we have a class called card. We have instance variables. We call these instance variables that belong to the instance of this class, the cookie.
Mm-hmm.
Okay. Let's actually then enhance this. Like, I hate building it like this.
Mm-hmm.
Okay. So let's just have a new method.
Mm-hmm.
Okay, that does go def to string. Okay. We can just return then an f string.
Yeah.
Of self label, self description. Okay?
Yeah.
And instead of doing it this way, we can do my print my card. So this returns a string, so we can print that out. Okay?
Yep.
So we do toString. And here it's the same thing. Okay? Now let's go back down here. And we get back the same thing.
Mm-hmm.
Okay? All good so far. Okay. So what does this actually look like? I mean, and again, what I'm about to show you is not exactly how that actually is in memory. Okay? But it's close. It's like it's a way that you can just use it to think about. Okay? So, again, my favorite way to draw memory is always like this. Okay. Now, it's not exactly, like, we don't care about the addresses. We just care about how it is laid out, just for the sake of visualization. Okay? And I'm gonna ignore, like, methods and things like that. Ignore methods and things like that.
Okay.
Okay. So somewhere here, I don't know where exactly, but just know, okay, somewhere here, you see this like orange square here? This is going to be the card class definition. Okay? It will just basically have things like init that will return back instance, and then it'll just have other things, the methods. Okay. Every time you create, and let's say a card, you just basically allocate regions of memory like this. So this here is my card. Okay, it gets its own label, its own description. And here was layer 7. This is blah blah blah. Okay? Then when you created a new instance of my card with my card 2, you basically created another region allocated to that called my card 2. Okay? And it also gets its own label and then description. This is not exactly accurate, it's just a way to think about it. Right?
Yeah.
You have this card class here that can basically give you back this guy and this guy. Okay? Remember, they have their own region. Okay? So, what that allows us to do now is we can create very modular code where we can model things. Like if you kind of think about this right now, this is actually what you could represent as like some flashcard, right? So then you can have like a stack of cards, for example, as a list, represented as a list. So stack of cards, card stack. You can see the card stack. Not really like a data structure card stack, but like a card stack like this. And then we can say, well, okay, now let's enhance it a little bit more. You know how this had only self? Why don't we actually give it an initial label and a description? So we can just say label, description. Okay? So then here, when we create the card, we can have the user just specify it right away when we construct it. Like this.
So these are arguments into
The init, the constructor.
Okay.
See, it's not always an empty, okay? Like you can actually give arguments here to kind of set yourself up even earlier.
Yeah.
So then you don't have to do the set and get thing unless you really want to. So this is actually a more concise way to do it. So in this case, OSI layer 6. Then we say this is the presentation layer of the OSI network model. Okay, then we can just get rid of these now. Now, it is much cleaner. Now, do we need this? We don't really need it this way. We can just say card stack dot append. Okay, we can just append. Sorry. Okay, we can just append whatever is returned from this function call, which is basically the constructor. It returns back an instance of the card. Okay? We do the same thing here. Okay? So we're appending cards to this stack of cards at this point. I don't know why is it? Oh, yeah, it's fine. Okay. Okay, so we have these two here. And we can do the same thing, where we can actually now do a for loop for card in card stack. Okay? We can do print card stack to string, because, oops, card. Okay? It recognizes it because it knows it's just a list of cards. Does this part make sense?
Yeah.
Where you're creating new instances of cards, it returns back basically an instance.
Yeah.
This constructor. Then we're going to append into the card stack. So at this point, we have 2 cards.
Yeah.
So we can just go through the card stack and print them out individually. So we will save this and run it. Oops, I have a typo. But you get the gist.
Yeah, I get the gist.
Okay, so that is basically a basic flashcard. Okay. Now, I think we shouldn't be printing it out like this. I mean, that's like the answers. Okay, so why don't we actually do something like this, where we kind of toggle between, okay, you want to show the label, and then you want to programmatically kind of flip the card to see the answer. Okay,
Yeah.
so maybe let's just introduce a new instance variable. Okay, we could say, well, show answer. Okay, we said that's false initially. That's like the state of the card,
Yeah.
right? Show answer, or is answer shown, or whatever. Okay, but notice how we don't have to initialize it. We don't have to take an argument to set this, nor do we need any of these setters and getters. You don't always have to have a setter or a getter for every single instance variable that you have. It's only if you want someone outside of your class to control an instance variable for that object. In this case, I don't think we care exactly, but let's say we can indirectly change this. It's like you don't have to explicitly call a setter and getter to change this. But what I can do is, and this will be clear, is let's say I want to be able to set show answer eventually. I could define a flip method that will then invert this to be, how do I invert it?
Not. Oh.
Not show answer. Okay.
Is it the shebang equal?
It's not shebang. It's bang.
Oh, sorry, bang.
Bang. It's fine. This is not. I think it's correct. We'll figure it.
Okay.
Okay. So flip. Flip will actually then do that. Okay. Now to string is fine. We'll just leave it like this. But let's define a new method that will actually display. Okay, display the appropriate string. So in this case, if, let's say, self show answer, okay, is true, what we want is to return the description. Otherwise, we can just return the label. So notice how this is writing off of this variable here. But then this variable can only flip what we call flip, meaning that if you're ready to flip. Okay, so we can actually display the card, and then whenever you're ready to flip, you call flip, and then call display again, and it'll show the label. Or not label, the description this time. Right, so initially when you call display, it can only show the label, but when you call flip, and then you call display again, it'll show the description.
Okay.
So we can test that out right now with this. So for every card, they get their own version of show answer.
Yeah.
So, let's play around. So instead of printing to string, okay, let's do card dot show or dot display first. Okay. Now we're going to do card stack. We're going to take the first card, we're going to flip it, and then we're going to do card in card stack again, and we're going to see what they display, each card.
Okay.
Okay?
Yeah.
So what's the code? We defined a new instance variable called show answer. We have two new methods that operate within that instance of a card. One called flip that will just kind of invert that show answer. If it's false, it'll be true. If it's true, it'll be false. Okay? And then one that will display based off of show answer, either the description or the label. Show answer true means that we want to see like the answer of the card. And then if it's false, meaning that we just show the default like label. You know how like you have a flashcard, the front and the back kind of thing.
Yeah.
Okay? And what happens if we just say card stack, the first one flip again? Okay, just for fun. Just show that we can toggle correctly. Okay? So then here this code is, okay, you know this code, now it just displays a card.
Yeah.
It should, since the show answer variable, the instance variable for each one of them are false, it should just display the label, both of these labels.
Yeah.
At some point, we're gonna flip the first card, this one, layer
Mhm.
7, and it should, when you iterate through the card stack again, it should show this one first, the answer, but then the next one, it should still show the label. Because we can flip that one,
Yeah.
okay? And then we'll flip the first card back, and it should be showing OSI layer 7 again.
Okay.
Okay, so let's test that out. So, oops. Oh, we didn't print. So, print. Okay. Oops. Okay. That's the right, not indentation, right?
Yeah.
Okay. Okay, so we displayed a card.
So this is the first flip.
Yeah, no, this is the first loop.
Oh, first flip.
Then we flipped once
Uh-huh.
on the first card. Then we run through the loop again and display what we have. So this right here.
Okay.
And then we flip the first card again, and then we iterate and display the card again.
Okay.
Do you see that?
Yeah.
So now we've modeled a flashcard.
Uh-huh.
So we're flipping.
Yeah.
Okay. So that's where I want to leave off today. I'm gonna commit this and then
That's cool.
let's add a git. I think it's just like this. Escape. Oh my gosh. Oh, it doesn't work that way. It's terminal. Okay, let's do Control C. Oh. Let's just
Don't we add something?
here. No, I want to add it up on top, so we can just do this. Okay. Okay. What?
Global spoken.